notice that if you look at the order of the letters, and I have triangle ABC and triangle PQR, and the triangles are congruent, angle A corresponds to angle P, angle B corresponds to angle Q, and angle C corresponds to angle R. So that's really important with congruence of shapes, that when you're listing their vertices, you list them in the same order. So then angle B is going to be congruent to angle Q, because those are the corresponding angles. So if you drew the triangles, you'd have like A, B, C, and then P, Q, R. So they have to go in the same order. Okay. If we have two triangles that are congruent, angle U is 32, so I'm just going to write little numbers over top. V is 43, and W is 105. What's C? Well, C and W correspond to each other, so C is going to be 105. Does that make sense? So, like, this just order things. If you go to the next one, ABC is congruent to UVW, so we want to know what is A. A is going to be the same as U, so A is going to be 37. And then it's the same thing with sides. You'd have AB is congruent to PQ, BC is congruent to QR, and then you'd have like CA is congruent to RP. So that goes back around the corner. Does that make sense? So BC is going to be congruent to QR. That's a terrible R. So we have these triangle congruence postulates, and these get used so much in triangle proofs. So you have side, 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 which says that if you have three sides of one triangle are the same length of three sides of another triangle, then the triangles are congruent. So that means all the angles will be the same as well. If you have angle, side, angle, same thing. If you have an angle and then a side that's congruent and then the following angle, and then you have side, angle, side. Now, what you do not have angle, side, side. Okay? I'm going to cuss, and I'm sorry, but there are no ASAs in geometry. All right? So, no angle, side, side. You have side, angle, side, or angle, side, angle, or side, side, side. Okay? I have an angle. Yeah, angle, and then a side, and then an angle. So that's going to be angle, side, angle. Here I have sides, all three sides. That's side, side, side. And here I have side, and then an angle, and then a side. Look at these. Since these are two triangles, they share a common side. Technically, this would also be 17 if we were to split them in half. But, you know, a side is the same length as itself. Right. So to make these two congruent, I need x to be what? X has to be 9. And then I have what kind of congruency? Side, angle, side. Perfect. Because I have a side and then an angle and then a side. Anybody on this first one? Pen. Side, angle, side, because we have the side and then the angle and then the side. B? And then what do I need this x to be to make these two triangles congruent? 28. And they'd be congruent by Well, actually, yes, to both of you. It's going to be side, side, side if I just look at the sides, or I can look at the fact that these are vertical angles here and make it side angle side. This one has two ways of it being true. No. It's technically, I think what the problem was looking for was side, 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 because they were asking you about the lengths of sides, but side angle side also works because these are vertical angles, so it's true. Side, 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 side angle side, and angle side angle. Yes. Okay. Now we have a theory, which is angle, angle, side, which tells me if two angles and a non-included side are congruent. So basically, you've got some triangle. You have two triangles, right? You would have angle, angle, and then a side. So the side is not between the two angles anymore. Now it's after them. So you could have either of these two sides, but not this one, to be angle, angle, side. And then you have hypotenuse leg. And if you recall, give me my triangle. If you recall, I didn't mean for that to be, but okay. The hypotenuse is the longest side across from the right angle. So what we have is, when you have hypotenuse leg, you have the hypotenuse, hypotenuses. I'm not really sure which is correct. But the two hypotenuse are congruent. And then one or the other of the legs. And then we have hypotenuse angle, which is kind of the same. You have your hypotenuse, and then one of the angles that is not the right angle. And it can be either angle. I have no right angles. I have two angles and a side, and the side is not in between them. So I have angle, angle, side. And then I have a right triangle, so I have a hypotenuse and another side, so that's hypotenuse leg. And then I have another right triangle. I have the hypotenuse and an angle, so that's hypotenuse angle. Yes. Hypotenuse angle, because we have a hypotenuse and an angle. Okay. So now we're going to have some proofs with this. So first we state a theorem. I have angle, an angle, and a side. If I have a square or a rectangle and it's cut along the diagonal, this is the hypotenuse. And the hypotenuse is the same as itself. So I have a hypotenuse leg. All right. I'll do the hard part. You guys can do the other two steps. No? Okay. So what I've got is that R and T are right angles, and that angle 3 and angle 4 are congruent. So I'm just going to go ahead and label that. QS is the same as itself. Anytime something is the same as itself, it's reflexive, like a reflection. And then if I have a hypotenuse and an angle, that tells me that the two triangles are congruent. First line is always given. So that's given, right? Okay, so what does that mean? If we're bisecting? Well, it does intersect, but to bisect is a specific kind of intersecting. Bisecting cuts in half. So that means that this length and this length will be the same. And then this length and this length will be the same because they're cutting each other in half. Okay, so that's what that means. So then that's the next line of our proof. We look at what the first given stuff is and then we say, okay, what does it mean? And then we go from there. So the next line of our proof is going to be that EF is congruent to FH and DF is congruent to FG. Because that's what it means to bisect. Okay, bisect cuts into equal halves. So it's the definition of bisect. So now I have two sides. And if I have two sides, if I look at my congruence, the ones that have two S's, I have side angle side or side side side. Those are my choices with two S's, right? So that means I either need to come up with this angle in between is the same or these other sides are the same. I don't have anything that'll tell me these other sides are the same. But I do have something that can tell me that the angles are the same. This angle and this angle, they're vertical. So I'm going to go ahead and number those just to make it easier because that way you don't have to give them all a bunch of letters. I'm going to say angle 1 is congruent to angle 2 because they're vertical. And now I have side angle side. Do you see that? So then I can say triangle DEF is congruent to triangle GHF because I have side angle side. And so the way I figured that out is once I had two sides that were the same, I knew that there were only two types of congruence that have two sides. And then I go from there to see which one I can make it be. Okay, I have angle A is congruent to angle D. You guys should all be able to tell me this one. Go. Thank you. Next one. Awesome. Okay, so I have angle A and angle D are congruent, so I'm going to label them. What I've done is label the given information. Okay, so I have two angles, and sometimes it's confusing to look at this all together, so if that's the case, you can just bring them out, like separate the two triangles. See what I did? I just basically split them apart. And then I have that these angles are the same. Wait. Sorry, these two are the same. I was getting my angles confused. Ah, darn it. Okay. So I have two angles. So I have angle and angle, angle and angle. Okay. BC is the same as itself, right? You're always the same as yourself? Okay, so that's reflexive. I was just looking at the picture wonky. So I have angle, 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 side. Do you see that? Angle, angle, side. Okay, so figures that are identical in shape and size are congruent. That means not only are all the sides the same length, all the angles are the same measure as well. And then corresponding are parts that are in the same relative position, so you can have corresponding angles and corresponding sides. All right, we have two congruent triangles. The sides are all the same length and the angles are the same. These tick marks indicate side length, and then with angles you get like little curves. So one curve, two curves, three curves. And then obviously the square indicates a right triangle. So what we have is congruency, and then angle A is going to be congruent to angle D. They're corresponding. So when you list this, this would be A, B, C, and triangle D, E, F. So angle A and angle D will match. Angle B will go with angle E. And angle C will match angle F. And then AB will be equal to DE. BC will be equal to EF. And then AC would be equal to DF. So all of the corresponding parts of the congruent triangles will also be congruent. The triangles are congruent only if their vertices can be matched. So to look at these two triangles, let's see if this one actually will work. Aha. So basically, if you look at these, hey, these are the same. That makes them congruent. You don't have to write all of that if you don't want to. These are different. That makes them not congruent. I think it gets too Frankenstein-y when you put the tick marks in the angles too. I don't like that. But this is another way that people do indicate angles is with tick marks. So for sure the sides are always tick marks, and then like I said with the angles, you either get tick marks or you get, you know, number of loops. But like I think that's very Frankenstein-y. So I like loops better. But it means the same thing. Okay, so are these congruent? We've got all the sides are the same. We've got all the angles are the same. So yes, they're congruent. So we want to identify that. So we say ABC is congruent to JKL. And you'll notice I've listed A and J in the same position because those are the congruent angles. Bless you. So angle A is congruent to angle J. Angle B is congruent to angle K. Angle C is congruent to angle L. AB is congruent to JK. BC is congruent to KL. And AC is congruent to JL. Now you'll notice I made a point to put the lines over. This is indicating I'm talking about line segment AB. And if I'm talking about congruent, I have to keep the lines over. If I don't want to use congruent, I can say AB is equal to JK. So this is the line segment AB. This is the length of AB. So the line segments are congruent, the lengths are equal. So that's what that bar over top indicates or doesn't indicate. We don't have to draw them though. Like I said before, if DEF is congruent to RST, then D is congruent to R, E is congruent to S, F is congruent, wow. F is congruent to T, DE will equal RS, EF will equal ST, and DF will equal RT. So if we're asked which angle is congruent B, which angle is angle B congruent to, you can either draw a picture and label it. Just remember that when you draw the picture, you go in the same order. And then you go, oh look, B and Q are in the same place. These are congruent. But if you don't want to draw a picture, I can just look at the order that the letters are in, and I can say, hey, these are in the same place. They're congruent. That's why it's important what order you write the letters in, because it means something. So, okay, so we've been given angle 1 is congruent to angle 2, and angle M is congruent to angle O. Those are both given. Okay, so I'm going to go ahead and label that. Angle 1 and angle 2 are the same, and then O are the same. Okay, and again, with the triangles together like this, it's sort of hard to see them. So you can slide them apart. That's an O. And we have these little corners. Now I need to either come up with a way to show that these two sides, because I have two angles, right? So my choices are angle side angle or angle angle side. So I'd have to either come up with a way to show that these two sides were congruent or that these two sides are congruent. Well, these two sides is really one side. So LP is congruent to itself. Anytime it's equal to or congruent to itself, it's reflexive. So those two triangles are congruent to each other because I have angle, angle, side. Okay, so we've got this picture and we've been given this information. Okay, so let's look at it. The first line, X is the midpoint of VU. X is the midpoint of this line. Midpoint means that this side and this side are the same length. So I'm going to write that down. Vx is equal to XU. That's definition of midpoint. Okay, so now I've got that labeled. Wx and Yx are congruent. That's given. So here's Wx and here's Yx. That's given. And then I have that angle W and angle Y are right angles. So I have right angle, which means I'm going to have hypotenuse in something possibly. So I look at the angle and I look at what's across from the angle and I look at that. My hypotenuses, whatever they are the same, right? So now do I have hypotenuse angle or a hypotenuse leg? Hypotenuse, yeah. So the triangles are congruent because of hypotenuse leg.